Okay, good evening to all of you. Today we are going to do simple harmonic motion, and in today's session of simple harmonic motion, we are going to concentrate on spring oscillations. Now, in spring oscillations, what are the things that you need to know? Number one, you know that in every simple harmonic motion, the primary reason why simple harmonic motion is happening, it is because of restoring force. So you know that the main reason why any simple harmonic motion, why does it happen? The main reason is due to restoring force. So restoring force is given by minus kx. K is the spring constant and x is the displacement. So that is number one. Number two, if you have springs connected to each other like this is one spring, this is another spring. If you have two springs connected to each other like this, then they are called springs in series. And in that case, the equivalent spring constant of them is K1 into K2 by K1 plus K2. So if you have two springs like this, one spring constant K1 and one is spring constant K2, then the equivalent spring constant of both of them will be K1 into K2 by K1 plus K2. If you have two springs connected to each other like this, so that is called parallel. Like this is spring with constant K1, this spring with constant K2, this is called parallel. So equivalent spring constant is K1 plus K2. And if the springs are connected like this, like K1 is over here and K2 is over here, then that is also considered as parallel. Okay, so the equivalent spring constant is K1 plus K2. So I am repeating again, if you have two springs connected to each other like this, one in front of the other, so then it is called series. The equivalent spring constant is K1 into K2 by K1 plus K2. If you have two springs connected like this, it is called parallel. Equivalent spring constant is K1 plus K2. If you have two springs connected like this with a mass in between, that is also parallel, then also the formula is K1 plus K2. So series and parallel. Okay. And what about the time period of simple harmonic motion? So the time period of simple harmonic motion, it will be 2 pi into root over m by k. So you can take any diagram, take this diagram or this diagram. There is a mass that has been shown, like this diagram, there is a mass that has been shown. So in this formula, 2 pi root m by k, m is the mass and k is the equivalent spring constant. So primarily these are the formulas related to spring oscillations. Okay. Suppose you have two blocks, their masses are m1 and m2 and they are connected by a spring like this, and this entire system is given an extension x0. So there are two blocks of masses m1 and m2 connected by a spring and it is given an extension x0. So it is given an extension x0. So after it is given an extension x0, suppose this block moves to the left by x1 and this block moves to the right by x2. So I am repeating again. There are two blocks of masses m1 and m2 joined by a spring. These two blocks, the spring joining them is given an extension x0. After that it is left. So suppose this block moves a distance x1, this block moves a distance x2. So the first thing we can say is that x1 plus x2 is x0. Second thing we can say is that this extension which has been given, due to that the spring force that is developed is an internal restoring force, so there won't be any change of center of mass position. So m1 x1 will be equal to m2 x2. So if you solve these two equations, then you will get x1 is m2 by m1 plus m2 into x0, and x2 will be m1 by m1 plus m2 into x0. So if you consider any one of the two masses, suppose m1, so the restoring force, it will be equal to minus k into the okay, actually using this equation we can say that x0 is x1 into m1 plus m2 by m2. So the restoring force is going to be minus k into x0. So that is minus k into this quantity, and acceleration will be force by mass. So that is minus k x1 into m1 plus m2 by m1 m2. So this will be the acceleration, and you know acceleration is minus omega square x. So therefore omega will be equal to root over k into m1 plus m2 divided by m1 into m2. So this will be the formula, right? This will be the formula. So I am repeating again. Time period, I am repeating again. There is a question that there are two blocks of masses m1 and m2 joined by a spring. that spring is given an extension x0. So due to that, m1 moves x0 to the right and m2 moves m2 moves x2 to the left. Now x1 plus x2 is x0. Also m1 x1 will be m2 x2. So if you solve these two, x1 will be m2 by m1 plus m2 into x0, and x2 will be m1 by m1 plus m2 into x0. So ultimately x0 will be x1 into m1 plus m2 by m2. So f is minus k into x0. So minus k into x1 into m1 plus m2 by m2. So acceleration is force by m1. So minus k x1 into m1 plus m2 by m1 m2. This is acceleration. Acceleration, you know, is minus omega square x. So omega is root over k into m1 plus m2 by m1 into m2. So this is the formula for omega. So time period is 2 pi by omega. So that will be 2 pi root m1 m2 by k into m1 plus m2. Now this is an important thing, that this expression 2 pi root over m1 m2 by k into m1 plus m2, and earlier we said that time period formula is 2 pi root mass by k. So this m1 m2 by m1 plus m2, this has got a physical significance. It is called reduced mass. So what happens is that if you ever have a pair of masses which are joined by an internal conservative force, then you can reduce the two of them to the center of mass. So m1 and m2 are two distinct masses. They are joined by a spring, or that is true, but spring force is an internal conservative force. So you can take this combination and reduce it to the center of mass. If you reduce it to the center of mass, then you can see the extension will be the extension of the whole spring. So that is x0, and the mass will now become m1 m2 by m1 plus m2. So this quantity m1 into m2 by m1 plus m2, this quantity is called reduced mass. So when you have a pair of masses, you can reduce the two of them to the center of mass, and then you can use reduced mass to do stuff like calculate the time period. So these are the complete details of spring force, and now based on this entire topic, that is spring force, I am giving you some homework, and the homework has to be submitted by 9 p.m. tomorrow, that means 9 p.m. Thursday. So now I will give you the homework. So there are three springs of spring constant K, K and K. These two springs are perpendicular, and this bottom spring is at an angle 45 degree with the horizontal. All of them have a spring constant K. So there is a slight, this is a block of mass m. There is a slight depression given to the block of mass m along the spring. So the question is what will be the time period? So this is question number 1. Question number 2. So there is a spring of spring constant K1 and there are two springs of spring constant K2 and K3. So, and the entire system is pulled by a constant force F. So the whole system is pulled by a constant force F. So you have to find the amplitude and the frequency. Okay, you have to find the amplitude and frequency of motion of this block. So that is number 2. Okay, question number 3. There is a spring of spring constant 100 Newton per meter. It is attached to a block of mass 1 kg and it is having oscillations with amplitude 0.1 meter. Now, when this particular block is passing through the mean position, at that time another block of mass 3 kg is gently placed on top of it. So when this block of 1 kg is passing through its mean position, another block of 3 kg is gently placed on top of it. The question is, after 3 kg is gently placed on top of it, what will be the frequency and what will be the amplitude? So this is question number 3. Okay, question number 4. There are two walls and there is a block of mass m moving with a velocity v towards another block of mass m. This block is attached to a spring and it is in equilibrium position. These two blocks have an elastic collision. After that, this block will obviously oscillate. All the surfaces are frictionless, all the collisions are elastic. So these two blocks will obviously collide very elastically, and after that this block will oscillate and then it will come back and again collide with this block will go and hit the wall. All collisions are elastic and all surfaces are frictionless. In this scenario, what is the time period of the oscillation, right? What is the time period of oscillation? That is the question. Question number 4. Okay, question number 5. There is a car, and on that car there is a spring, and it is attached to a block of mass m. The mass of the car is capital M, the mass of the block is small m. So the spring is stretched through x0 and then released. So, and it has been informed that the surfaces are frictionless. The surfaces are frictionless. So the question is that what are the amplitudes of the block and the car, and what are the time periods of the block and the car. So once again, there is a car, it is on a frictionless surface, its mass is capital M. There is a block small m, it is attached to a spring, the spring is extended through x0 and then released. So after that, after the spring is extended and the mass is released, what are the amplitudes of small m and capital M, and what are the time periods of small m and capital M. So these are the 5 homework questions, and you will have to do the homework by 9 p.m. tomorrow, that is 9 p.m. of Thursday, right? So I'll end the meeting for now. Thank you, and bye all of you.